Alright, so let's learn how to measure the behavior of electric circuits using two essential tools, voltmeters and ammeters. These devices allow us to observe the voltage and current at different points in a circuit, helping to ensure proper operation or diagnose problems when something goes wrong. The basics of measuring circuit values. At the heart of both ammeters and voltmeters is a sensitive device called a galvanometer. This tool detects current through the interaction of magnetic fields and electrical currents. Here's how it works. A current flows into the galvanometer's coil, which is positioned within a magnetic field. The magnetic force on the coil causes a needle to deflect, and the degree of deflection indicates the current passing through. From this basic principle, we build ammeters to measure current and voltmeters to measure voltage. Ammeters, measuring current. An ammeter measures the current through a particular component in the circuit. To use it, the ammeter must be connected in series with the resistor or device where current is being measured. Key concept: internal resistance of ammeters. Ammeters have an internal resistance, denoted as R. Ideally, this resistance should be very small to avoid interfering with the circuit's operation. When you connect an ammeter, its internal resistance adds to the circuit's resistance. If the internal resistance is too high, it would cause a voltage drop, altering the circuit's behavior. To minimize interference, ammeters are designed with a shunt resistor. This resistor provides a parallel path for most of the current, ensuring only a small fraction flows through the galvanometer. Example 1. Let's calculate the equivalent resistance when measuring current through a 5 ohm resistor using an ammeter with an internal resistance of 0.1. The equivalent resistance is the sum of the resistor and the ammeter's internal resistance, 5 ohms plus 0.001 ohms, which is approximately 5 ohms. As you can see, the internal resistance of the ammeter has minimal effect on the circuit. Voltmeters, measuring voltage. A voltmeter measures the potential difference, or voltage, between 2 points in a circuit. Unlike ammeters, voltmeters are connected in parallel with the component being measured. Key concept: voltmeters also have internal resistance, denoted as R. The internal resistance of a voltmeter should be very high to prevent current from flowing through it. A typical voltmeter might have an internal resistance of 10 megaohms. This high resistance ensures that the circuit's behavior remains unchanged while measuring voltage. Example 2. Let's measure the voltage across an 8 ohm resistor in a circuit where the voltmeter's internal resistance is 10 megaohms. First, calculate the equivalent resistance of the resistor and voltmeter using the parallel resistor formula. The result is approximately 8 ohms. Since the equivalent resistance is effectively unchanged, the measured voltage across the 8 ohm resistor will be accurate. Practical applications. Here are some key takeaways for using these tools. Always connect ammeters in series with the component of interest, and always connect voltmeters in parallel across the component of interest. To ensure accurate readings, use ammeters with low internal resistance and voltmeters with high internal resistance. Practice challenge. Let's test your understanding. First, you connect an ammeter with an internal resistance of 0.2 milliohms to measure current through a 10 ohm resistor. What's the equivalent resistance? The answer is 10 ohms plus 0.002 ohms, which is approximately 10 ohms. Next, you connect a voltmeter with a 10 mega ohm internal resistance across a 4 ohm resistor. The equivalent resistance is approximately 4 ohms. Advanced example. Consider a circuit with a 60 volt battery and 3 resistors, an 8 ohm resistor, a 5 ohm resistor, and a 20 ohm resistor. We'll measure the current through the 5 ohm resistor using an ammeter and the voltage across the 8 ohm resistor using a voltmeter. First, simplify the circuit to calculate the total current using Ohm's law. Total resistance equals 33 ohms. The total current is 60 volts divided by 33 ohms, which is approximately 1.82 amperes. For the 5 ohm resistor, the current is 1.82 amperes. For the 8 ohm resistor, the voltage is 1.82 amperes times 8 ohms, which is approximately 14.56 volts. And that's how we measure voltage and current in circuits using ammeters and voltmeters. By mastering these tools, you'll unlock the ability to analyze and troubleshoot electrical systems effectively. For more detailed lessons and practice problems, head over to codetc.me. Stay curious and keep learning.